All right, guys, so continuing on with the review. So today we're going to try to tackle number 25 through 40. Okay, so on number 25, you guys, first of all, this formula will be given to you on the test, so you don't have to memorize that, okay? So if you want to use a formula, you do have to know, though, like what everything means. So let's write that down. So what does the Y mean? So the Y means the final amount of whatever you have. The N means the original or the initial amount of whatever you have. You guys, the E is just a constant. It's on your calculator. You don't have to know that. Okay, the K is the constant of growth or decay, which in this case we're looking for, and the T is the time. So let's see what we've got here. It says after 9 years. So 9 years is definitely your time, so the time equals 9. Half of a 20 milligram sample of a radioactive element is left. So what's half of 20? Well, half of 20 is 10. That means 10 is left. So that means that you started with 20. So the original was 20 and the final was 10. Okay, now you guys, one thing I notice here that this radioactive element is decaying. It's getting smaller and smaller as time goes by. That means that your K has to be negative. So kind of keep that in mind. If you're not getting a negative answer, you're doing something wrong. Okay, probably you're switching the Y in the end. So let's plug this in. So we have Y, which is 10, equals N, which is 20, e to the K times 9. Notice I left the K as a K because that's what I'm looking for. Find the K. Okay, now I need to get that 20 away from here, so I'm going to divide both sides by 20. 10 divided by 20 is 1/2, and I have 1/2 equals e to the, K times 9 is 9K. I'm just going to write it like that. Looks better. Now look, I really need to get rid of that e, and the way that we get rid of an e is to take the ln. So I'm going to go ln of 1/2 equals ln of e to the 9K. And remember, whenever you have an ln and an e, you guys, that's just going to cancel out. The 9K drops down. So now I have ln of 1/2 equals 9K. And then divide both sides by 9. And then just plug this into your calculators. Let me plug it into mine. Do it with me. Make sure you understand how to do it. Okay, so you have ln. Remember, ln is right below the logarithm on your calculator. Okay, so you have ln. 1/2 is 0.5. You can plug it in that way and then divide it by 9. And it came out to be negative 0.077. Remember I said K should be negative because it's decaying, and it was. All right. Now number 26, same formula. Okay, so we have Y equals NE to the KT. I'm not going to write this out again here from above because we already wrote it down once. So let's see, what is our final and original amount? So it says for a certain strain of bacteria, K represents 0.775. So hey, this time we know what K is. When T is measured in hours, how long will it take 2 bacteria to increase to 100? So this is your original, and this is your final. Okay, so let's plug this in. So the Y is the final, so I have 1,000 equals, the N is the original, which is 2, and then it's e to the K, which they gave me, was 0.775 T. Okay, now you guys, this time because this bacteria is increasing, our K should be positive, right? So let's see if that actually happens. So again, just like above, I'm going to divide both sides by 2. 1,000 divided by 2 is 500. So I have 500 equals e to the 0.775. I'm going to write it this way. I'm sorry, there's not enough room on this. And then to get rid of an e, we're going to ln both sides. So I'm going to have ln of 500 equals ln, I forgot my t, sorry, ln of e to the 0.775 t. Again, the ln and the e cancel out, so I have ln of 500 equals 0.775 t. And then to solve for t, all I have to do is divide by that 0.775. So t is going to equal ln of 500 all over 0.775. So let's plug that in. And again, this better be positive, right? So ln of 500 divided by 0.775. And I got 8.018. So about 8.02 or something like that. So the time is 8.02 hours. Okay. I apologize. I kept saying the K should be positive. I'm not even solving for K, but you guys notice like the K was positive because it was increasing. Ignore me, I'm tired, but we're good. The answer is time equals 8.02. Okay, now number 27, it looks like a different formula, but you guys pretty much it's kind of the same. Look, you still have like a Y, it's kind of like an A, and it's kind of like the P. You still have this E, you still have this E. Instead of a K though, we have something called a rate, and then the time is exactly the same. So let's write out what these variables mean, and you'll see that they are very similar to number 25 and 26. Okay, so what does A mean? A means your final amount. P means the original amount. The R is the interest rate. And you guys, this one's an important one. It has to be as a decimal. Okay, they're always going to give it to you as a percent. Like notice there's 6%. You need to change that to a decimal. So we'll talk about that in a minute. And then the T is still your time. Okay, so let's see what we can plug in. Let's see what they gave us. So they said, assume $100 is deposited in a savings account. So this is the original amount. The P is 100. Your grandma gives you $100, you put it in the bank, okay? The interest rate is 6%. So the rate is 6%, but as a decimal, remember to change 6% to a decimal, we either do 6 divided by 100 or just move the decimal 2 places to the left, which is 0.06. If you do not change it, you will get it wrong. So please be careful with this one, okay? When will the money be double the original amount? So if we double this 100, that means multiply times 2. That means the final amount is going to be 200, okay? And the question is when, so we are looking for the T variable. So plugging this in, we have that A equals 200 equals, and just plugging into this little formula. Again, this formula will be given to you. P is 100. E to the 0.06t. So just replaced all my variables. And you guys, if you look, this is exactly the same as number 25 and 26. So we divide by 100, giving us 2 equals E to the 0.06t. Now to get rid of the E, I'm going to ln both sides. So I'm going to do ln of 2 equals ln of E to the 0.06t. And then remember, ln and E cancel out, so I have ln of 2 equals 0.06t, divide by 0.06, divide by 0.06, and plug that into your calculator. You guys, time can never be negative. So if you're getting a negative time, you're doing something wrong. So divided by 0.06, and I got 11.55 years. Okay, so time equals about 11.55 years. All right. Okay, number 28, exactly the same question, exactly the same formula. A equals PE to the RT. So this time we invest $10 at 8% compounded continuously. When will the investment be worth 100? So this 10 is your original, so that's your P. Okay, the 8%, this is your rate. So it's E to the 0.08t. Remember, I have to change it to a decimal. And the final amount, that's your A, that's worth $100. Okay, so again, how do we solve this? We divide by 10. These cancel, so 100 divided by 10 is 10 equals E to the 0.08t. To get rid of the E, we're going to ln both sides. So ln of 10 is ln of E to the 0.08t. Guys, by the way, this belongs to this triangle. Isn't that cute? I reformatted this review and I messed that up. Sorry about that. Okay, so the ln and E cancel out. So I have ln of 10 equals 0.08t. And then dividing by 0.08, we are going to get that T equals, and let's plug that into our calculator. So we're going to plug in the ln of 10 divided by 0.08. And that gives me about 28.78 years. So 28.78. All right. Okay, that finishes the logarithm unit. Now, the next part, this is where we start with trig. So you guys, again, I said this was supposed to be angle A. So let's look at this. It says find the degree measure of angle A. And once it to the nearest degree, we'll do that in a minute. Okay, so these, because we have a right triangle, we can use SOHCAHTOA. Hope you remember what that meant. Okay, so is this going to be a sine, a cosine, or a tangent function? Well, let's see what we've got. Okay, we're trying to find angle A. So I'm trying to find this guy right here. And what they gave me is the opposite side and the adjacent side. So remember, opposite and adjacent is TOA, OA, right? That's your tangent function. So how do I set this up? I'm going to go tangent of the angle that I'm looking for equals opposite over adjacent. Now, the way to get rid of that tangent, a lot of people go, oh, let's divide by tangent. You can't, okay? The only way to get rid of that tangent and separate it from the A is by taking its inverse. So we're going to do tan inverse of this, and then we're going to do tan inverse of the other side as well. So the tan inverse and the tan cancel out, leaving me with A equals tan inverse of 2 over 7. Now, this you need to plug into your calculator. Make sure that you are in, we even put this here, degree mode. If you're in radian mode, you're going to get it wrong, okay? So let's type it in. So tan inverse is on the, you just hit second tan, that'll do tan inverse. And then 2 divided by 7. Okay, check this out. I was in the wrong mode. I'm using my kid's calculator. Okay, let's try this again. Okay, 15.94. So this is about 15.94, but then they wanted me to put it to the nearest degree. So I would say that's about 16 degrees. Okay. Now a little typo on number 30 here. I apologize that when I reformatted, I completely forgot about this. Use the same diagram as in number 29, the one above. Okay. So look, let's again redraw this triangle because we have different sides on it, so we might as well. This is still A, this is still, oh, that's C, not B. This is C, this is B. And it says that little c is 21, that's the side, and little b is 18, that's this side. And this time I'm looking for angle B. So I'm trying to find angle B. Now let's see what kind of sides they gave me. You don't have to come up with your own, use what they gave you. I have an opposite side, and I have a hypotenuse. Remember, the hypotenuse is always opposite the 90. So I have opposite over hypotenuse, and you guys, that ends up being so, OH for opposite over hypotenuse. So I'm going to use my sine function this time. So I'm going to say sine of what? The trig functions always go with the angles. So the angle that I need here is B. So I'm going to go sine of B. The opposite side is 18. The hypotenuse is 21. Okay. Again, how do I get rid of the sine? To do sine inverse of both sides. Okay, so these cancel, and it's going to give me that B equals the sine inverse of 18 over 21. Again, make sure when you're plugging this in that you're actually in degree mode, and let's see what we get. So second sine of 18 divided by 21. And you guys, this gave me 58.99. If you didn't say to the nearest degree, but let's go ahead and do it, I would pretty much say that's 59 degrees. Okay? All right, change the following to radians. Now, look, this will not be given to you. You need to know this, okay? So to change something from degrees to radians, we're going to multiply by pi over 180 and then reduce the function, okay, or the fraction. Okay, so if I multiply this by pi over 180, put this over 1, multiply straight across, you get 225 pi all over 180. Now, what goes into both of these numbers? A 45 goes into both of these, so if I divide both by 45, I'm going to end up getting 5 pi over 4. And you guys, I kind of went quickly through this one because I did this with you in class today. Let's go a little bit slower with number 32. So same idea, multiply by pi over 180. Put this over 1, so that's negative 315 pi all over 180. Same idea, you guys, 45 goes into both of these. Okay, close to 45. Let me erase that. Let's try my notes. There we go, 45. Okay, how many times does 45 go into 315? Well, you can count it out if you want. It's 45, 90, 135, 180, 225, right? Then we have 270 and then 315. So that's 7 times. So this is going to be negative 7 pi over, and then 180 divided by 45 is still going to be 4. So this is negative 7 pi over 4. Okay. Now going backwards, how do I change something from radians to degrees? So on this one, from radians to degrees, I'm going to multiply by 180 over pi. So I'm going to do the exact opposite to try to get rid of that pi. So if I multiply this by 180 over pi, notice there's a pi on top and a pi on the bottom, which means I can cancel them out. And this is negative 5 times 180 over 12. Now, sadly, this will be on the no calculator section, so you have to know how to reduce these. And what I like to do, I don't like to multiply straight across. It makes it too big. I kind of look for like, is there something that can actually reduce? 180 and 12 are both even, so I'm going to go ahead and go with that. And you guys notice 6 goes into both of these. So let's divide both of these guys by 6. So what am I going to get? I'm going to get negative 5 times 180 divided by 6 is 30, and then 12 divided by 6 is 2. Now I'm still going to like kind of look at these guys. 30 divided by 2 is what? That's 15. So this is really negative 5 times 15, which is negative 75 degrees. Okay. All right, same thing with this guy. I'm going to multiply by 180 over pi. These guys cancel, so I'm left with 4 times 180 all over 5. Okay, nothing can happen with the 4 and the 5, but 5 goes into 180. How many times? Well, 5 goes into 18 3 times with a remainder of 3, and 5 goes into 36 times. So this is going to be 4 times 36. And if I go ahead and do that on the side, 36 times 4, so 6 times 4 is 24, carry the 2. 4 times 3 is 12, plus 2 is 14. So this is going to be a nice 144 degrees. All right, almost done. What is the least positive? That means the smallest positive angle I can possibly come up with. That is coterminal. You guys, to get coterminals, there's 2 ways to do this. If you're in degrees, you're going to keep adding or subtracting 360 as many times as you need to get the desired answer, right? If you're in radians, you're going to do the same thing, but add and subtract 2 pi, because 360 and 2 pi are the same thing. Okay, so notice, what are we in? Because I see pi's in the questions, do you see the pi's? That means that I'm in radians, so I'm going to add and subtract 2 pi as many times as I need. Now the question is, should I add 2 pi or subtract 2 pi? Well, I'm looking at this angle. This angle's pretty darn big already. I want the smallest positive angle, so let's subtract to make this one smaller. So I'm going to go ahead and subtract 2 pi, which means I need a little common denominator. So the common denominator is 3, so I'm going to multiply both of these by 3. So really, what am I subtracting? I'm just subtracting 6 pi over 3. That's another way to write 2 pi, over and over and over again. So let's see, I have 20 pi over 3 minus 6 pi over 3. That's my 2 pi, and that's going to be 14 pi over 3. Now, is that the smallest positive one? I think I can subtract 6 pi over 3 again. Let's do it again. So that's going to be 8 pi over 3. Is that the smallest one? Let's try again. I'm going to subtract 6 pi over 3 again. That gives me 2 pi over 3. Now, is that the smallest positive angle? I think so, because if I subtract 6 pi over 3 again, it's going to go negative. Does that make sense? Okay, same thing with this one, negative 4 pi over 3. You guys, same common denominator. So this time, because it's negative and I want to make it positive, I'm going to add 6 pi over 3. That's the 2 pi. So this will give me 2 pi over 3. Okay, I want the least positive. That's the least positive one. Now, reference angles. If you want a little cheat sheet for what a reference angle is, you guys, let's say I had a terminal side like here. Okay. So that's some angle, right? That just went all the way around. Okay, I'm just randomly picking something. Okay, a reference angle is an angle that is formed by, the terminal side and the x-axis, and you always want to pick the smaller angle, the acute one. That's your reference angle. Okay, so let's see what it is for 150. I like to draw these out. 150 degrees is somewhere right there. There's the terminal side. Here's your reference angle. Okay, so if this is 150, this guy has to be 30 degrees to make 180. So a reference angle for 150 is 30. Now for 225, actually that's a really nice picture of 225, but I'll redraw it over here. Okay, 225, this is 90, 180, 225, somewhere over here. Okay, remember the reference angle, again, is formed by the terminal side and the x-axis, but you want to pick the smaller of the angle, so that's the angle that I'm looking for. So look, if this right here is 180 degrees, how much more do I need to go to get to 225? I need to go 45 degrees more. So the reference angle for this guy is 45 degrees, okay? And then these are super duper simple. If it's pi over 4, pi over 6, or pi over 3, here's your reference angle. It's just pi over 4. Here's your reference angle. It's just pi over 6. Okay? All right, so you guys, I hope that helped. Tomorrow I'll make another video for you guys on the next 20, okay? Have a good night.